Besides being at home, Grand Canyon is my favorite place on earth.
Yeah. So, Steve, tell me, what do you see here?
When we look at Grand Canyon, we see the inside story to the ground beneath our feet. And we kind of have a layer cake here, don't we, of strata that have been eroded for our benefit to see the inside structure of the earth. These same layers are also in Colorado. They're also in Illinois, also in Pennsylvania.
So when you say sedimentary strata, you're talking about the layers that we see?
Yes. So the lowest layers are formed first. Those are sediment grains that were mixed, separated, and flowed in here from different directions and accumulated one on top of another. And then, of course, naturally, they convert to rock.
So you're saying that the solid ground we're standing on right now, if we went back in its history, it'd be liquid?
Yes. So the ocean is doing some amazing things, and water of incredible power is depositing the layers we see in the canyon.
And are there fossils in all of those layers?
There are marine fossils through all the layers. But the standard explanation is there were 17 different advances and retreats of the ocean over the North American continent, and it was extended over hundreds of millions of years.
And what is the evidence that you see here that would say that doesn't seem to make sense?
The 4,000 feet of flat-lying strata in the canyon are flat, and relative to one another, we look in between the strata layers and we don't see the passage of time in between layers.
You mean erosion?
Erosion, especially, and channeling on any great scale is not visible. And then we look at the strata themselves, and they provide evidence of rapid, very rapid sedimentation. Just minutes or hours is all that's needed to make layers.
Well, tell me about the story of these layers. I mean, how did they get here?
In the 600th year of Noah's life, on the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up and the windows of heaven were opened. My understanding is the ocean floor upheaval occurred. Some type of magma or earthquake propelled the oceans over the continent.
So that's why we get these marine fossils in these layers.
Yes, and we have 6 months the waters prevailed upon the earth, another 7 months or so for the water to subside. The 4,000 feet of strata probably represents the early and middle part of the global flood right here in Grand Canyon. We have other strata locally in this Grand Canyon region. That's called the Grand Staircase. We have about 10,000 feet, 2 miles thickness of strata on top of the Grand Canyon.
Higher than where we are.
Higher than where we are. And that represents the later stages of the flood and the retreat of the floodwater. This surface was beveled by retreat of floodwaters. And as the flood retreated into the newly formed ocean basins, then the continents probably uplifted, and the ark, of course, was landed in the high country in the Middle East.
Well, there's some people who say that that record is about a local flood.
I believe it's a global flood, and all the high hills or the whole heaven were covered, a universal statement. But that mountains have risen since then, and we shouldn't measure the depth of the floodwaters by the present mountains of the earth, which are largely created during the flood and after the flood.
Well, the fact that we have all of these layers would be unknown to us if we were standing on them, somewhere else, but they're known to us because they've been cut out. How did that happen?
Well, it was the story that we all learned in grammar school. Okay, Colorado River, over tens of millions of years, cut the Grand Canyon. Most geologists have jettisoned that idea. It's hard to sustain a canyon like this for tens of millions of years. You can't imagine a canyon enduring that long with erosion.
Is that because it would have eventually the sides would have collapsed and broken down? Then how in the world do we get this all carved out?
Well, there are lots of theories, and personally I like the idea of catastrophic erosion by drainage of lakes.
So after the flood, we have these large bodies of water, these lakes that are trapped.
There's evidence of the big lake in the Painted Desert, a place called Hopi Buttes, about 500 cubic miles of water in this huge lake.
And so the dam breaks and all of that massive amount of water then is now pouring out and carving this.
Yes, and how long would it take to erode Grand Canyon? Maybe weeks, but not millions of years. Time is not a magic wand that solves all the geologic problems of the world. Jettison that way of thinking about millions of years and then start thinking about catastrophic process like you've seen at Mount St. Helens, and that'll help you understand Grand Canyon.
Everywhere we looked, Steve showed me evidence of the incredible power of moving water. It quickly laid down these enormous layers, then quickly eroded them away. Steve wanted to show me where the floodwaters first hit the continent, so he took me deeper into the canyon.
Stephen, you said you were going to bring me to the bottom. You weren't kidding, were you? We're at the bottom, aren't we?
So we're in this big side canyon to the main Grand Canyon, and we're looking at the granite basement rock, which is the core of the continent, if you will. And then we see the flat-lying strata on top of it. The boundary between the granite rock below and the Tapete sandstone above is this surface we call the Great Unconformity.
Why does it appear to be such a stark line? I mean, it's clear.
I think it's an erosional boundary of colossal scale. We're looking at something that shows the magnitude of flood flow over a surface.
And is it just here?
The Great Unconformity is continent-wide. I've seen it, I believe, in the Middle East. It's over in Europe. It's in Africa, and here it is under the North American continent.
So we've got this layer. How thick is this layer? What goes up from here?
Well, we have the Sauk mega sequence here, if you will, 1,000 feet of sandstone, shale, limestone that goes continent-wide. There are 4 other big sequence packages of strata that sit above it. Those are also very continuous like this. What we're seeing here is rather representative of the rest of the world.
It makes one really question the notion that this all happened because of a small local flood. We're talking about something enormous.
The power-moving water was beveling and pulverizing rock, depositing great thicknesses of layers and calling our minds to think about a global flood.
The conventional story is entirely different, though. It would say that there is a lot of time between each of these layers.
Some people have said that the Great Unconformity boundary here represents 500 million years.
You mean between the granite we see in that first layer of the sedimentary rock?
Yeah, they say that there may be 500 million years there. Okay, and that's what their explanation of Earth history would ask them to consider. Yet when you come here and look at this, nearly a featureless plain. It's not exactly a plain, but it's a gently rolling surface. And would that be the product of billions of years? Or would that be the product of the power of water planing off a surface? Time is foreign to a good explanation here. And so we want to explain what we see. Everywhere we look, we see the power of water. And it's water on a colossal scale, and that's the story here in Grand Canyon. It's not a little water and a lot of time. It's a lot of water in a little time.
Time really is the central issue when talking about the history of the Earth. How much time did it take to form what we see around us? It seemed clear to me that a global flood would have transformed the Earth quickly. Yet I know many people think that the world formed slowly over billions of years. What was the real difference between these two views of time? I needed to talk to someone who could tell me more about science and history and time. Since my background is in computer science, we met at a place where I had personally experienced some of that history. As we looked at the exhibit, I was reminded how much smaller and more powerful computers have become since I first started using them. Paul said our changing assumptions about computers were really a series of paradigm shifts.
So when I was 19, I read Thomas Kuhn's classic, The Structure of Scientific Revolutions, where he describes this notion of paradigm